5 problems which can be solved by using greedy approach. Knapsack problem, job sequencing with deadlines, Huffman codes, single source shortest paths, and optimal merge patterns. 5 problems that we are going to discuss upon. I'll first start with knapsack problem. So a knapsack is a bag. You'll be given a bag with capacity M. Right? Then you'll be given N objects where each object I will be associated with a weight Wi and profit Pi. Each object has a weight and it has a profit. Now, the objective of knapsack problem is you have to fill the knapsack that maximizes the total profit. That is your objective function. Okay, now let us see. Here I have taken a problem. The number of objects that you have been given are 7. Okay, you have been given 7 items. And the size of the bag is 15. Right? And now assume that this N7 or number of items, it's nothing but you have items 1, 2, 3, 4, 5, 6, and 7. Okay, now this is the weight of each item. Assume that it's kgs, maybe. The weight of object 1 is 2 kilos. The weight of object 2 is 3 kilos. The weight of object 3 is 5 kilos, and so on up to 7th object. Each object will also be given a profit. Assume that profit is in rupees. That means if I sell this object 1, I'll earn a profit of 10 rupees. If I sell object 2, I'll earn a profit of 5 rupees. So as such, there are 7 objects. Each object has a weight and each object has its associated profit. Now, I have been given a bag. I have been given a bag which can accommodate 15 kgs of weight. It can accommodate 15 kgs of weight. And now I have to fill these objects. I have to fill the objects into this bag such that I can fill 15 kilos of objects, and I have to select such objects to fill where the earned profit is maximum. The profit is maximum. That's the objective. Now, what is the problem here? Problem is filling the knapsack bag. What is the constraint here? Constraint here is the knapsack bag can take up only 15 kilos of objects. That's the constraint. Now, what is the objective function? The objective function is to fill the bag with objects such that the profit is maximum. The profit is maximum. So, you have been given a bag whose capacity is M. You will be given N number of objects where each object has a weight and it has a profit. The constraint is that the knapsack capacity is M. So you have to choose all the objects that are to be filled into the bag such that total weight is less than or equal to m. So these are the objects. Xi is the object that you have chosen to fit into the bag. Ith object ni meer choose cheskunnaru bag lo veyadaniki, and its weight is wi. And as such, you have chosen many objects to fill into the bag. The sum of weights of all those objects should be less than or equal to m. That is the constraint. The objective function is you have to fill the knapsack to maximize the total profit, maximizing objective function. So that means you have selected some items X to fill into the bag. Each item has a profit, and the sum of all profits must be maximum. As such, you have to select the objects to satisfy the constraint and to satisfy the objective function. Now, what is this Xi that I have written here? Wi is the weight of the ith object. Pi is the profit of the ith object. Now, what is this Xi? Xi can be either equal to 0 or 1 or a fraction between 0 and 1. Xi is a value, any value between 0 and 1. If I have some object I can put it into the bag. I will not put it into the bag. I may partially fill it into the bag. So there are three choices I'll have to make at each stage. Selecting an item I using the selection procedure, I'll do that. After selecting an object I'll have to decide whether I have to put it into the bag or not. If I will put it into the bag completely, full item, I'll put it into the bag, then Xi value will be equal to 1. I may partially put it into the bag. I may put half item into the bag. Then Xi value will be some fraction. I may decide I'll not put it into the bag. Then that particular ith object ki Xi will be equal to 0. Now you have to take up a selection procedure. In each stage, you are going to select an object I. Now you are going to decide whether you want to put this object I completely into the bag, partially into the bag, or you will not fill it into the bag. Accordingly, for that ith object, Xi value will be between 0 to 2. Now you have n objects. For each object, you'll decide to put it into the bag or you'll not put it into the bag. So X1 is your decision for object 1. X2 is your decision for object 2. X3 is your decision for object 3 and so on up to object n. For each object, you'll decide you'll put it into the bag or you'll not put it into the bag. Okay, now when you have these three options of fully fill it into the bag, partially fill it into the bag, or you'll not fill it at all, there are three options. Then such a problem is called as a knapsack problem in general. There will be something called as 0-1 knapsack problem. It is a 0, 0, 1 knapsack problem. This is a variety of knapsack problem where you'll not have partially filling. The option undadu. Either you can fully fill the item or not fill it at all. Partial filling will not be available. Then such a knapsack problem is called as 0-1 knapsack problem. Now, if you see this example, when this will become knapsack problem, when it can be called as 0-1 knapsack. Now check this weight. I'm saying that this weight is in kgs, right? So object 7 is of weight 1 kilo. Object 6, its weight is 4 kilos. Now, what is this object 6 and what is this object 7? If I'm assuming that all these objects are vegetables, object 6 is tomatoes. I have 4 kilos of tomatoes. Now, when I'm filling these tomatoes into the bag, it's possible that I'll fill all the 4 kilos into the bag. I'll not at all fill tomatoes into the bag. I may fill only 1 kilo of tomatoes into the bag. I have 4 kilos available, but I'll take up only 1 kilo into the bag and I'll fill it into the bag. So partially filling is possible if these objects are vegetables. Half kilo, 1 kilo, 2 kilos, I can fill into the bag. But if these objects are home appliances, a TV, a fridge, I cannot fill a half of the TV into the bag. I'll have to either fill it or I'll not fill it. Partial filling is not possible in such scenarios. So given type of objects, if partial filling is possible, it's knapsack problem. If partial filling is not possible, it is 0-1 knapsack problem. Now I'll work out this problem here, assuming that partial filling is possible. Now, okay, so now we'll start. The first solution I'm going to frame. I have to decide the selection procedure. Now, among all these items, if I start filling up into the bag, I have object 1 to 7. On what basis should I select an object? So I'll take highest profit. The selection procedure or the optimization measure is the maximum profit. So I'll select an item based upon its profit. So among all the objects that are available from 1 to 7, I'll first choose the item with the highest profit. So the item with the highest profit is 6. Sixth object has highest profit among all the available choices. This is your stage 1. Selecting an object with highest profit. So what is the first item that I'll fill into the bag? So here is my bag and I'm going to first fill object number 6. Right? So I have selected object number 6. I have selected. Now, how many kilos are there? It has 4 kilos. So 15 kilos low. 4 I have already filled up. What will be the remaining? Remaining will be 11. Right? Now I can fill up the bag with 11 more kilos. Okay, now this is your step 1. You have selected object number 6. Then second step. Second step again, I'll choose the object with the highest profit, and the 6th object you have already selected. Remaining objects. So I'll select an object with the highest profit. Now that object is 3. Object 3 has a profit of 15. Now can I select this object? No, I cannot select, because the remaining I have remaining capacity of bag is only 11. So ilaga each time in each stage, I'm going to select an object with the highest profit. This is one solution. It's a feasible solution. Feasible solution. Feasible solution is where you are going to satisfy the constraint that the capacity of the bag is 15. That's the constraint. The objective function is the profit must be maximum. That is also satisfied. So this algorithm that you have designed using greedy approach is a feasible solution. Now, next solution I may come up with. Instead of at each stage choosing the object with highest profit, I can choose the item with least weight. This is the item with least weight. This is the item with least weight. That is also possible. Stage 1, I'll choose the item with the least weight. The item with the least weight is 5th object. So into the bag, I'm going to put object number 5 and its weight is 1 and its profit is 6. Stage 2, I'll again choose another object with least weight and I'll put it into the bag. Now, what is the motto here? Why I am selecting least weight object? I want to fit more number of objects into the bag. I want to put more number of objects into the bag, assuming that if I fit more objects into the bag, I'll get more profit. This is also a feasible solution, but it is not optimal solution. These two solutions just now I have discussed, putting the items with the most profit into the bag, a feasible solution. Fitting more objects into the bag, that is also a feasible solution, because both the solutions are satisfying the constraints and maximizing the profit. Both are feasible solutions, but they may not be optimal solution. Optimal solution is where you'll get the maximum possible profit. Among all the feasible solutions, the one which will give you the maximum possible profit, that's your optimal solution. The two solutions I have told just now, these are feasible, but they are not optimal. So for that, to produce an actually optimal solution, I'm going to use this selection procedure. This selection procedure is P by W, profit by weight. Now you can see how I got this 5 here. 5, I have got object 1's profit divided by its weight. Ante this profit 10 is being earned for an item with weight 2 kilos. Now I am trying to find out for 1 kilo, how much profit will I earn? For 1 kilo, I'm going to earn a profit of 5 rupees. Now here, this is object number 2, whose profit is 5, and you'll earn profit 5 for 3 kilos. Now, what is the profit for 1 kilo? 5 by 3, which is 1.6. So I have found out all the profit by weights for all the n objects. Once this is done, so once this is ready, now I'll start filling the bag. Now I'll start filling the bag. Which item will I first put into the bag and how much of it? Okay, so I'll go with the maximum P by W value. The maximum of the P by W value. So now in stage number 1, I am going to select the object with the maximum value. So this is the object with the maximum P by W value. For 1 kilo itself, it is giving me 6 profit. So what I am going to do, I am putting this object into the bag. Okay, so now I am going to fill up this solution vector X, which will be from 1 to 7. 1 to 7. Each object I'll try to put it into the bag, partially fill it, or I'll do not fill it. So I have this objects 1, 2, 3, 4, 5, 6, and 7. 7 objects are there. Now, if I decide that I'll put 5th object because it is giving me maximum profit with 1 kilo. So I'll write a 1 here. That indicates that item 5, object 5 is fully put into the bag, fully filled into the bag. Done. When I put this 5th object into the bag, the maximum M capacity is 15. 15 lo 1 kilo నేను fill up chesanu. Remaining will be 14. 14 more kilos I can put into the bag. Now, stage 2, I have to select another item which I can fill it into the bag. So remaining items lo check it. I have first object with P by W 5. I can fill it. Now, if I want to fill object 1. In the solution vector, I'll put 1 here, indicating that fully I'll fill. Fully until 2 kilos are available for object 1. All the 2 kilos, I'll put it into the bag. If I put 2 more kilos into the bag, the remaining will be 12. Now, stage 3. Object 5 వెళ్ళిపోయింది full ga, object 1 kuda వెళ్ళిపోయింది. So, object 5, object 1, both are done. So remaining objects low. Which is the one that has highest profit? It is object number 6. Can you fill it? All the 4 kilos, can you put it up? Yes, all the 4 kilos, I'll put it up into the bag. If I'm completely filling it, then the solution vector, I'll put a 1. 6th object, I'm fully using it. Then remaining objects. I have object 2, 3, 4, and 7. I have object 3 and 7 with same weight. I'll take object 3. If I'm filling object 3, whose weight is 5 kilos, can I put all 5 kilos into the bag? Yes, it's possible to put all 5 kilos into the bag. If I'm using completely, then in the solution vector, I'll place a 1. Then I have 2nd object, 4th object, and 7th object. I'll take 7th object because it has profit 3. If I'm taking 7th object, can I completely fill it into the bag? Yes, it's possible. Its weight is 1, so I'll completely put it into the bag. If I'm completely putting it into the bag, I'll fill a 1 into the solution vector. Now 2 more kilos I have to fill. So I'm going to select object number 2, whose P by W is 1.6. Now, can I put complete object 2 into the bag? No, it's not possible. Object 2's weight is 3, but the remaining capacity of the bag is only 2. So I cannot completely fill up object 2. Then what I'll have to do? I'll fill up only 2 kilos of object 2. That means object 2, I'm not completely filling, but I'm partially filling. Weight available is 3, but I'm using only 2 kilos into the bag. So you have to write here 2 by 3, which is 0.66. Now you know how you are getting a fraction. Either you are filling the entire item into the bag, or you are partially filling an item into the bag. Now you can see here object 4 is not being selected to fill it into the bag. Object 4 is not in the bag. Then you'll write a 0 here. Fill it into the bag, 1. Partially fill it into the bag, fraction. You'll not select it to fill it into the bag, it's a 0. Right? Now, this is your solution vector. This is your solution for the given knapsack problem. Now, how you are going to find out the constraints are being satisfied or not satisfied? How you'll try to find out what is the profit that you have achieved? Right? So for that, what I'm going to do, I'll try to find out the weight. What is the total weight? The constant that has been given is the maximum weight that you can fill into the bag is 15. So 15 kanna ekku fill up cheyakudadu. That was the rule. Now find out the weight. First item fully filled up and its weight is 2. Second item, it is partially filled up. So the weight that you have used is 2. Third item, all 5 kilos you have used. Fourth item, you have not used it to fill it into the bag. Fifth item, you have filled it completely. That is all 1 kilo you have filled. Sixth item, all 4 kilos you have used. Seventh item, all 1 kilo you have used. Now add this, 2 plus 2 is 4, plus 5 is 9, plus 0, plus 1, 10, plus 4 plus 1, which is 15. So the constraint is satisfied. Now what is the profit that you are earning? Profit, first item key, profit is 10. Second item key, profit is 5, but you are not completely filled up. You have used only 2 by thirds. So that will be 2 by 3 into 5. The profit will be 2 by thirds of the item into 5. Plus third item key, profit is 15. Fourth item key, anyway you have not used it. Fifth item key, the profit is 6. Then the profit is 18. Then the profit is 3. Right? So 10, 25, 31, 41, 49, 52, 2 by thirds of 5, maybe around 53 or 54, you'll get the profit, right? So this is your knapsack problem. So given any knapsack problem, there may be many solution vectors. So this is the given problem here. There are 3 objects. The bag capacity is 20. The profits are 25, 24, 15. The weights are 18, 15, and 10. I have found out some solution vectors. You can see there are 4 solution vectors that were possible. This is the weight. The maximum weight is 20. And these are the profits. So you can see the 4th solution here. Object 1 is not at all filled into the bag. Object 2 is fully filled into the bag. Object 3 is half filled into the bag. Half of the item is filled into the bag. So partials are also possible. So as such, there are many different solutions that are available. All are feasible solutions because they are satisfying the constraint. Any solution that satisfies the constraint is a feasible solution. So the maximum bag capacity is 20. That is the constraint. So all the 4 solutions are satisfying the constraint. So it is feasible solutions. But which is the optimal solution? An optimal solution is a solution that gives you the maximum profit. So you can see here, fourth feasible solution is giving you the maximum profit. So it is your optimal solution. All right. So you can check out the algorithm in the textbook for whatever process I have discussed just now. This is the algorithm representation for the greedy knapsack problem. Knapsack problem solved using greedy approach. Okay, and the time complexity of this algorithm is big O of n, where n is the number of objects that are given for you.